Hello, my name is Max, and I will be introducing Deferred Acceptance, a Julia package for solving and analyzing school choice problems. School choice problems generalize a problem you may have encountered in a class on algorithms or game theory called the stable marriage problem. In school choice, we are a school district, and we're trying to figure out which students to send to which school. Each student has submitted a preference list. My first choice is this school, my second choice is that school, and likewise, each school has ranked the students, or more likely, given them a test. We want to find a matching that is stable, which means that if I get rejected from, say, my first choice, then all the students who got in have to be smarter than me, that is, higher on the school's preference list. And the school can't have any empty seats. Otherwise, I would be justifiably upset. One way to find a stable matching in this many-to-one context is using the Gale-Shapley algorithm for stable marriage, which in school choice is typically called deferred acceptance. Needless to say, this package implements several variations of deferred acceptance, including random tie-breaking mechanisms that try to optimize for student welfare. This algorithm is cool, but by looking at a single stable assignment, it can be hard to conclude much about the overall preferability or competitiveness of each school. A recent development in the school choice literature is a nonatomic framework that enables this sort of econometric analysis by modeling students as a probability distribution over the set of possible preference lists and scores. In this case, stable matchings can be characterized uniquely by a vector of score cutoffs at each school. One downside is that the space of student types is very large. However, with some simplifying assumptions, we can compute the expected cutoff vector numerically using the tools of quantitative economics. And this functionality is a somewhat distinctive feature of deferred acceptance, and it's the one that leans most heavily on Julia's efficient compiler. If I may briefly discuss my own research, one limitation of DA as an analytic tool is that it assumes schools mostly care about filling their capacity. But in the real world, and especially when we look at college admissions, many schools' objective functions are a combination of the size of the entering class and the quality of the admitted students. In this case, we can associate with each school a demand curve that shows how many students the school will get as a function of its score cutoff. And I'm working on using publicly available admissions data to predict the shape of these demand curves and deduce schools' admissions objectives. Thanks for listening. Here are my vital signs. Help me learn to code. I look forward to your feedback.